Hello, human geographers. We are back at it again. Tonight we're talking about chapter 14 in our textbook. Now, we're not going to read it. We don't have any study guide packets that go along with it, but there are a few topics that I want to cover to make sure that we are very clear about humans' use of the environment, humans' use of resources, what resources we use, what impacts those have, and what potential future resources are there out there that we could potentially use. So let's go ahead and get started. So we start out by taking a look at a couple of different definitions. We start out with the definition of non-renewable energy, a source of energy that is a finite supply capable of being exhausted. And there are some examples. The most obvious example are fossil fuels. Energy source formed from the residue of plants and animals buried millions of years ago. Hence the name fossil fuels. It is a fuel source like petroleum, natural gas, coal, that takes millions of years to compile, which is the reason that it's in finite supply. It takes millions of years for this to become an energy source. It's not a renewable source for humans. All right. On the flip side of that, you have renewable energy, a source that has a theoretically unlimited supply and is not depleted when used by humans. And examples include things like hydroelectric power, geothermal, fusion, wind, solar, examples like that. All right? And we're going to be taking a look at all of these today, some of their implications, positives, negatives, statistics, things like that. So we start out with non-renewable energy sources. And we start out by looking at the different ways that these are calculated. Since they're non-renewable, we kind of need to know how much do we have. And so there's two different types of reserves. Proven reserves, again a definition, the amount of a resource remaining in discovered deposits. So we know how much is there. Okay? For example, okay, 5/6 of the world's energy comes from three sources: coal, petroleum, and natural gas. All right? And in fact, in the United States, 1/2 of the electricity that is produced here in the United States comes from power plants that burn coal. Okay? So coal is a huge part of what is generating electricity here in the United States. All right? So since most of our energy comes from these three sources, again, that's coal, petroleum, natural gas, we need to know how much we have. So at our current rates of consumption, the proven petroleum reserves would last us 43 years. For natural gas, it would last 49 years, and with the proven coal reserves at the rate of consumption that we are currently at would last 131 years. So there is a finite supply, and that's obviously assuming that consumption rates don't increase. Right? Obviously, if they decrease, then that would prolong this period of time. But if consumption rates increased, then that rate of time would go down. All right. Now, on the flip side of that, there are also potential reserves. All of those numbers that we just looked at are based on the proven reserves, the things that have been discovered. But potential reserves, by definition, are the amount of a resource in deposits not yet identified, but thought to exist. All right. And there's a few different ways that we can analyze potential reserves. One of them is in undiscovered fields, so areas that we didn't know existed. We can also utilize new techniques, what they call enhanced recovery. So even in the proven reserves, we might be able to potentially extract more through enhanced recovery. And then there are also unconventional sources, things like oil sands and oil shale. We're going to talk about each of those here in just a minute. And so here is a link to an article about fracking, or hydraulic fracturing. And essentially what it is utilizing high pressure water mixed with certain chemicals that blast oil shale to crack these rocks so that natural gas can be extracted from them and utilized. So again, this is an unconventional source along with oil sands, but it is something that's gaining a lot of attention here in the United States. It is something that is being discussed and debated and licensed in the United Kingdom. It's also the topic of environmentalists and what are the potential impacts of this. One potential theory is that hydraulic fracturing or fracking is leading to an increase in instability with the ground and leading to potential tremors, um, earthquakes, things like that. So that's one on the potential side of effects of hydraulic fracturing as an unconventional source. So let's take a look at the distribution of these reserves of the energy sources that comprise 5/6 of the world's energy. All right. And so when we start with coal, about 2/3 of the world's proven reserves are in the United States, China, and Russia. To add some more statistics to that, China extracts about 39% of the world's coal, and the United States extracts about 16%. On the petroleum front, oil wells can be found, or oil proven reserves are found both on land and in the water. So on land, for example, Southwest Asia produces about 40% of the world's petroleum. Central Asia produces about 15%, Russia about 11%, and the United States about 10%. As far as water sources, areas where there are oil wells that are off the coasts of land, we've got the Persian Gulf, which is near the Middle East, the North Sea. That was something that we discussed way back in political geography when we talked about the UNCLOS and how much water belongs to a territory. The Caspian Sea, which is in Central Asia, and the Gulf of Mexico, obviously off the coast of the United States and Mexico. But what is kind of interesting now is the emergence of another country, and that is Canada. Canada is now thought to have about 13% of the world's petroleum reserves, second behind only Saudi Arabia. However, much of the oil or petroleum is tied up in oil sands, which are in Alberta. Now, we just pointed out that oil sands were an unconventional source. We're going to talk about that a little bit more here in a minute. And then finally, the last form of fossil fuels that we're looking at that are a major contributor for world energy is natural gas. And natural gas we see predominantly in Russia. In fact, Russia has about 1/4 of the world's natural gas reserves. And together, Southwest Asia, the Middle East, and Central Asia combine for more than half of the world's natural gas reserves. And obviously, we talked about Southwest Asia with regards to the international trade approach and identifying unique economic assets. Well, in this case, we see that both petroleum and natural gas are unique economic assets that Southwest Asia and countries in Southwest Asia are able to utilize. Now, one topic of conversation that you might hear about here in the United States are a couple of pipelines that connect Canada, run through the United States, and run down to the Gulf of Mexico where there are refineries. One of those is the Keystone XL pipeline. Another one is the Dakota Access pipeline. Both of these pipelines run through the United States and connect up into Alberta for those oil sands that we mentioned that Canada is using to extract petroleum, leading to it being identified as the country with the second most petroleum reserves behind Saudi Arabia. And so this has been a controversial issue here in the United States for quite some time. It was halted during the Obama administration. It is back on during the Trump administration. And so here's a link into a little bit of what it is, the politics behind it, and a little bit of why it is potentially controversial on both sides of the aisle. Now, as far as consumption goes, we mentioned that those three sources of energy, that is coal, petroleum, and natural gas, combined for 5/6 of the world's energy. So who is using that energy? And so we have two lines here. The purple line is going to be MDCs and the green line is going to be LDCs. And so while in the early 2000s into the earlier part of this decade, the consumption gap is fairly close, LDCs now consume more energy than do MDCs. However, on a per capita basis, and reminder that that is a per person basis, it's not even close. So this is a map. Let's ask the usual questions. What type of map are we looking at? And at what scale are we analyzing this? And we see that it is a choropleth map at the national scale. And so we can see that the biggest consumers on a per person basis, that is per capita, is going to be in more developed countries. All right, so when we look at this, is energy consumption per person a good indicator of development? And we see that generally, yes, it is. All right, about 1/2 of the world's energy is consumed in MDCs, and about another half is consumed in LDCs. Now, we just pointed out that LDCs actually do consume a little bit more than do MDCs. But on a per person basis, MDCs consume about 1/3 or have about 1/3 of the population of LDCs. So that means that on a per capita basis, they're consuming about 3 times more energy per person in MDCs than do LDCs. And in fact, North America, and more specifically Anglo-America, is the largest consumer of per capita energy, consuming 1/4 of the energy. 25% of the energy coming from Anglo-America, with only about 1/20 of the population. Okay, so we consume 25% of the energy, only have about 5% of the population. So what are the potential effects of this energy consumption? Well, pollution is a big part of this. As you guys will potentially talk about in AP Environmental Science, one of the big things is we have to be specific when we use pollution as a cause. It's not just enough to say, oh, well, it'll lead to pollution. We need to be specific in terms of what type of pollution we're talking about. And there's 3 major types. There's air pollution, water pollution, and land pollution. We're going to look at each of those. So starting with air pollution, by definition, air pollution is the concentration of trace substances. That's the part that I want you guys to underline. Trace substances, such as carbon monoxide, sulfur dioxide, nitrogen oxides, hydrocarbons, and solid particulates at a greater level than occurs in average air. So the question that naturally followed up, at least for me, was, okay, well, what's in average air? What's the composition? Because if we're looking at a higher concentration, what constitutes a higher concentration? What are the current levels at, so we can understand the impact of this? Well, in average air, about 78% of it is nitrogen, 21% is oxygen, and less than 1% is argon. Now, if you're adding that up, that's about 99% of the air. And in fact, trace gases, those trace substances that we mentioned in the definition, comprise only 0.04% of the air. So air pollution is, by definition, an increase in that 0.04% of gases like carbon monoxide, sulfur dioxide, nitrogen oxide, hydrocarbon, all these different types of things that are a fraction of 1% of the air. So even a little increase can have a huge impact. So let's take a look at that. So some of the biggest causes of air pollution are going to be things like motor vehicles, which in particular contribute to carbon monoxide, hydrocarbons, nitrogen oxides, and mainly that is driven by the consumption of petroleum. Right? We fill our cars with gas, that comes from petroleum. And then industry. and power plants. Now remember that about half of the electricity in the United States comes from power plants powered by coal. And what those power plants in industrial manufacturing are releasing are sulfur dioxides as well as the solid particulates, the pieces that you might actually be able to see in the air. All right. Now there are natural causes of air pollution as well, things like volcanic activity, air and wind currents, wildfires, the natural decaying process of microbes, things like that are natural contributors to air pollution. But there are also man-made causes as well. Things like mining and smelting, industrial processes that we already pointed out, transportation, construction, the heating of buildings, the incineration of waste, landfills, so agriculture we've talked about in the past. So there are a lot of different causes that lead to that. So the natural question that comes from this is, what are the effects of this air pollution? All right, we know that air pollution is an effect of both natural and man-made activities, in particular things like transportation, motor vehicles, as well as industry and power plants. But what's the effect of air pollution? What does that lead to? Okay, so we have two charts here, and the one on the left is looking at CO2 emissions, carbon dioxide. And we can see that as time has gone on, as we moved through the era of industrial revolution, as we got into the early parts of the 20th century, we saw CO2 emissions skyrocket. Then, when we take a look at the same kind of time period, we're starting in the 1800s and extending into the 20th century and so on, and we're looking at global temperature. And that brings up the concept of global warming. So we want to make sure that we understand what this concept is before we talk about, the politics of it. Okay? So essentially, these trace gases that we said are a component of air pollution, okay, the concentration of trace substances. Well, these trace gases, like CO2, can block or delay the return of some of the heat leaving the surface that is heading out for space. What this essentially does is raises the Earth's temperature. Now, by burning fossil fuels, one of the trace gases that is emitted is carbon dioxide. All right. Now, this is added to by the fact when we cut down and burn trees just naturally rotting. We did talk about the natural effects as well. So much so that tropical areas that used to be CO2 sinks, meaning they're taking in carbon dioxide from the atmosphere, are now CO2 emitters. They put out more CO2 than they absorb. And again, we mentioned that that CO2 gas blocks and delays the return of that heat to the atmosphere, keeping that temperature here, and that's raising the global temperature, as we can see on the graphic on the right. Now, temperature increase of only a few degrees could lead to the melting of the polar ice caps. It could raise the level of ocean, and that means that coastal cities like New York, Los Angeles, Rio de Janeiro, Hong Kong, all potentially could be susceptible to floods. Now, the term that you'll also hear about this, global warming, is really just the rising in temperature. Climate change refers to a broad range of global phenomenon. Okay? This is different than weather, all right? So if you see a snowstorm and you're like, that's weather. That's local. It's short term. It might take, a day. It might last a week or even a couple weeks, okay? But climate change refers to global phenomena, which includes things like temperature increases that are associated with global warming, but also includes rising sea levels, ice loss in glaciers around the world in areas like Greenland, Antarctica, the Arctic, as well as extreme weather events that might be increasing in frequency. So we have to understand the difference here, and this is a link to NASA, so this is the US government, explaining the difference between weather, global warming, and climate. We already said that weather and climate are two different things. Weather is local and short term, whereas climate is global and long term. And one element of climate change is associated with global warming. So we just want to understand those differences. So if it's still not making much sense, here's a link that can take you to an area that would hopefully help to make it a little more clear. So we talked about air pollution. Now let's get into water pollution. All right. We use water for a lot of different things. Obviously, things like drinking, cooking, bathing, recreational activities, as well as the fact that it's home to many different types of edible aquatic life. So, feeding ourselves as well. The average American uses about 1,400 gallons of water a day. So the issue of water pollution is definitely something that certainly impacts us. All right. So when we take a look at some of the causes, some of the sources of water pollution, all right, we start with water using industries. Industries like steel, chemical, as well as paper production and food processing, all potentially lead to contamination of water sources. Municipal sewage. All right, so when we're talking about cities, obviously access to water is a big part of this, and getting sewage from homes is another element of that. Wastewater in MDCs, water that carries our waste from our homes, in MDCs is treated and then returned to a local lake or river, body of water, something like that, to then be used later. However, in LDCs, much of the wastewater returns untreated to lakes and rivers. And so that's certainly a big issue from a health and sanitation standpoint in many LDCs, and in particular, slums and squatter settlements within LDCs. And then finally, agriculture. This we have talked about before, the potential of runoff, water runoff, carrying with it herbicides, pesticides, fertilizers, things like that can get into rivers, lakes, bodies of water, and impact the water that we use for all the things that we listed at the beginning: drinking, cooking, aquatic life, all these different types of things. And then our last type of pollution, we're talking about land pollution. So there's two major sources of land pollution. One is solid waste disposal, right? And that used to largely be in landfills, but landfills have largely been replaced with recycling programs as well as incineration. And so there's a link here to an article about Swedish incineration, because in Sweden they're actually using all of their rubbish, these landfills, to heat their homes. They're incinerating it, they're burning it, and using it as a source of heat. In fact, they actually have to import trash to keep their incinerators going. Okay? And there was another article that I was reading about this that actually said not only are they importing it, they actually charge countries to take their waste. Because these countries are like, where are we going to put our trash? Where are we going to put this? And Sweden's like, we'll take it, but you got to pay us a little bit. So it's a money-making operation that they're using to generate energy to heat their homes. Really a fascinating example here. And then finally, the second part of this is hazardous waste. Okay, now, hazardous waste can sometimes be things like unwanted byproducts of manufacturing as well as waste. And the big issue is that we have to find a safe and secure location to store this waste. Now, we're going to be talking about this a little bit later with regards to nuclear waste, which is obviously different when we're talking about land pollution, but it really isn't that different because we're still talking about trying to find a safe and secure location for it. So we talked about non-renewable energy sources: coal, petroleum, natural gas. All right, we talked about the effects of it. Now, what are the alternatives? As of 2011, when our textbook was published, about 15% of the United States energy was coming from other sources of energy, things that were not non-renewable. Okay, 8% of that 15% was from nuclear, and then 7% was from renewable sources. Now, a little update: As of 2018, about 18% of US energy is coming from renewable sources. So we're going to take a look at that a little bit later. But there's some different types that we're going to go through. We're going to talk about biomass, we're going to talk about hydroelectric, wind, geothermal, and solar. So we start out with nuclear, which is not a renewable source of energy. Sometimes it's lumped in with that, but it is an alternative to fossil fuels. And about 1/6 of the world's energy is coming from nuclear energy, partly because it's able to produce more energy with less consumption. All right. For example, 1 kilogram of enriched nuclear fuel contains more than 2 million times the energy of 1 kilogram of coal. So the same amount, 1 kilogram of nuclear, 1 kilogram of coal, and nuclear is able to produce 2 million times more energy. Now, several of the concerns are addressed below. So here are some of the problems, some of the concerns with regards to nuclear energy. The potential for accidents, and there have been accidents in world history, in U.S. history, and in fairly recent world history. Going back, 3 Mile Island took place in Pennsylvania in 1978, so that was here in the United States. I believe that was the worst nuclear accident in U.S. history. Chernobyl is arguably the worst nuclear accident in world history, and that was in the Ukraine. At that time, the former Soviet Union in 1986. And the most recent element of this, or the most recent accident, was at the Fukushima Daiichi nuclear plant in Japan that had a partial meltdown after a tsunami and subsequent earthquake. And so there's that it's not just the potential for accidents. We do have evidence of accidents in the past. Okay. There are other elements like where to store radioactive waste, and that is especially a big topic for us here in Nevada because in 1987, Congress designated Yucca Mountain, which is 90 miles northwest of Las Vegas in Nye County, as a permanent repository for nuclear waste. And it was approved in 2002, but funding ended in 2011. It has been discussed about reopening it, creating the potential for lots of jobs in Nye County, but also the potential for nuclear waste to be stored in a state that doesn't have a nuclear power plant. And so there's that element of it. Obviously, other concerns like bomb material, the fact that there are limited uranium reserves. Plutonium is another alternative, but it's a little bit different. And then it's very expensive. All right, and obviously that makes this a little bit more limited in terms of what countries are able to utilize this. So getting into elements that are considered renewable, we start with biomass. Now, biomass makes up about half of renewable energy, and this is coming from essentially wood as well as other, crops and different things like that. All right. In particular, the top crops that are used are things like sugarcane, corn, and soybeans. Now, of the biofuel energy in the United States, about 48% comes from what are classified as biofuels, things like ethanol. Now, again, we talked about ethanol in our agriculture unit as a byproduct of, or what corn can be used for. So now we're kind of making that connection. And then about 41% comes from wood, and 11% from other sources, things like municipal waste. All right. Brazil is another example that uses biomass fairly extensively. And so it's kind of interesting to look at the cross of that because we know that deforestation of the Amazon rainforest is a big issue, particularly in Brazil. So is there that connection? And then issues, it's not as efficient as some of the other forms of energy, or I guess it would depend on the type of crop being used. Wood being used reduces the fertility of the forest. We talked about that as far as rainforests being CO2 emitters rather than sinks. And then the fact that we can use biomass for other purposes. Okay, so when we use corn for ethanol, well, that might be farmland that could be used to grow food for people. Our next element that we're going to look at is hydroelectric power. Now, hydroelectric, what that means is using water to move water wheels and things like that that will then generate electricity. And in fact, it's the second most popular source of electricity behind coal. A couple of countries that use it fairly extensively. Brazil is the most populous country that relies on hydroelectricity. Makes sense when we look at the physical geography and we look at the river system like the Amazon that flows through Brazil. But many LDCs rely on it because it's something where, you know, if you have access to moving water, then you're able to utilize it. Canada actually gets about 2/3 of its electricity from hydroelectric energy. The United States is the fourth leading producer of hydroelectric energy, but doesn't use very much of it. Only about 8% of our energy comes from hydroelectric. China, one example of the potential impacts of hydroelectric is the Three Gorges Dam. And the Three Gorges Dam is regarded as an environmental disaster because in the aftermath of this construction project and things like that, there was a decline in the water quality in that area. We saw endangered wildlife. We actually saw the extinction of some rare forms of vegetation. And that's a big concern with regards to this, is the damaging of ecosystems in, around, upriver, downriver from hydroelectric power plants and dams. As far as wind power goes here in the United States, about 1/3 of the country is windy enough for wind power to be utilized. In particular, a number of states that we should know have a lot of wind farms: North Dakota, Texas, Kansas, South Dakota, and Montana. So kind of the northern border states, but also Texas and Kansas. Obviously, some of the benefits are there's going to be less physical change to the environment. We're not talking about building dams. We're not talking about, you know, drilling for oil, you know, things like that. And our potential is just barely being tapped. There's a lot of room for more consumption of wind power. There are definitely some concerns with this. It can be quite noisy, which in urban areas or even in rural areas, areas with people, and people don't necessarily like that. It can be lethal to animals that get caught in these turbines, in particular airborne animals, birds, bats, things like that. And obviously is a visual blight on the landscape. If you've ever driven to California, chances are you've seen some of these wind farms. And so that changes the cultural landscape. And depending on your perspective of it, can be not something that people are in favor of. As far as geothermal energy goes, essentially by definition what it is energy from steam or hot water produced from hot or molten underground rocks. And this is especially common where crustal plates come together. So the Ring of Fire in the Pacific, when we take a look at all of these different examples, many of them are in and around the Pacific: California, New Zealand, Japan, Indonesia, all examples of areas that have that are in, near, and around, adjacent to the Ring of Fire in the Pacific. Iceland has a lot of volcanic activity there. There's a really interesting book that I'm reading right now called The Boiling River, which is all about this part of the Peruvian Amazon where geothermal energy is literally boiling a river. So it's really fascinating to look at how the Earth is able to do that and the potential there for generating energy. Finally, the last piece that we want to look at is solar. And only about 1% of the U.S.'s electricity comes from solar. And this is something that has a lot of potential benefits. It is a resource that cannot be depleted or destroyed so long as the sun is in the sky, which, we're good for the next 5 billion years. No one owns it. It's not exclusive to anyone. It doesn't damage the environment. It doesn't cause pollution. There's a lot of opportunity for this. And there's two different types of solar. One of them is what is known as passive solar, so no mechanical devices. And then there is active solar, okay, which uses devices like photovoltaic cells and flat plate collectors to harness that solar energy and use it to generate electricity. So we leave you tonight by looking at some of the statistics that are related to U.S. energy as up to date as we can get them. All right. So we can still see that almost 2/3 of our energy is coming from fossil fuels. And in particular, now the updating number, natural gas is kind of past that. That's probably more due to fracking, hydraulic fracturing of shale and harnessing the natural gas from that. But again, about half of our energy is generated by coal-powered plants, at least historically that's been the case. And I would say probably for the AP exam, that's probably what they will still say because they won't have these updated numbers factored in. About 20% is coming from nuclear. That's going to be about 4/5 of the energy here in the United States. And numbers are starting to creep up. This is from 2017 where they had about 17% of the energy coming from renewables. In 2018, they reported it at 18%. And so it's kind of interesting to look at how these numbers kind of stack up and things like that. So thank you so much. Have a wonderful night, and we'll see you back in class.